Unit 3, Activity 5, Rational and Power Functions. This activity focuses on two new types of functions. The first one, rational functions, which are the fractions of polynomials, and the power functions. Power functions have the form y equals k times x to the power of n, where the exponent can be any real number. We will not study these functions in depth. Instead, this will be an opportunity for you to apply the skills you have obtained this semester to answer questions and problems that you are less familiar with. Obviously, we cannot cover every type of function that you are likely to encounter when using math in your other courses or on the job, so it is important for you to leave this course with the ability to use your modeling, problem solving, communication, and technology skills to think through new scenarios. So remember, this is the last lecture for this semester. Learning outcomes: explain the meaning of the values in context, solve problems using power and rational functions, use equations and graphs to solve problems, and use what you have learned about functions and solving equations algebraically and graphically, and to work with functions that model various real and realistic situations. So we'll start with some skills and review problems. Solve the following equations. Number 1, 6 over x equal to 20 over 5. We can cross multiply this. So that is 6 times 5 is equal to 20 times x. 6 times 5 is 30 is equal to 20x. Then divide both sides by 20. And simplify. 20 over 30 is 3 over 2. Next, number 2, 4 over x equal to 20. Here we can multiply this so that it is equal to 4 is equal to 20x. And then divide both sides by 20. 4 over 20. 4 and 20 are both divisible by 4, so we simplify that. That is equal to 1/5. Next, number 3, let's multiply these two, just like what we did for problems 1 and 2, so that we have x minus 10 is equal to 3x, and we can add 10 both sides. So x is equal to 3x plus 10, and then subtract 3x both sides. This is negative 2x is equal to 10, and divide by negative 2, so that x is equal to negative 5. Okay. Then number 4, square root of x is equal to 100. Here, what we do is we can square both sides to solve for x, so that x is equal to 100 squared is equal to 10,000. Number 5, 5 squared of x plus 10 is equal to 25. First we subtract 10 both sides. So 5 squared of x is equal to 25 minus 10 is 15. Then divide both sides by 3. Square root of x is equal to 15 divided by 3 is 5. And just like what we did for number 4, to get rid of the square root, we square both sides. So this is x. 5 squared is 25. Now number 6, square root of 2x plus 4 minus 5 is equal to 3. So we add 5 both sides. So the square root of 2x plus 4 is equal to 3 plus 5 is 8. And then again, we square both sides. so that this is 2x plus 4 is equal to 8 squared is 64. Then subtract 4. 64 minus 4 is 60. And last one, if we divide both sides by 2, x is equal to 60 divided by 2 is 30. Okay, now let's start with our class discussion. The circulation time of a mammal, that is average time it takes for all of a mammal's blood to circulate once and return to its heart, can be modeled with the function m equals 17.4 m raised to 0.25, where m is the mass in kilogram and c of m is the circulation time in seconds. Letter A, find the circulation time of a hippo which has a body mass of 2,520 kilogram. So we know the circulation time of mammal is modeled with the function c of m is equal to 17.4 m raised to 0.25, and we want to find the circulation time of a hippo which has a body mass of 2520 kilogram. So we want to solve c of 2520. So what we do is substitute 2520 to m, and don't forget it's raised to 0.25. So use a calculator. And that is equal to 123.28 seconds. Next, letter B, find the body mass of a horse whose circulation time is about 1.5 minutes, and 1.5 minutes in seconds, because c of m is the circulation time in seconds. 1.5 minutes is equivalent to 1 minute is 60 seconds and a half is 30, so that is 90 seconds. So if this is 90, c of m is 90, so 90 is equal to 17.4 m raised to 0.25. Then if we divide 17.4, that is 5.17 is equal to m raised to 0.25. Just to recall that 0.25 is the same thing as 1/4. So you can rewrite this as 5.17 is equal to m raised to 1/4. So to isolate m, and the exponent is 1/4, we can raise both sides by 4. So that 1/4 times 4 is equal to m. So 5.17 raised to 4 is 714.43, or approximately equal to 715 kilograms. Okay, then now letter C, graph the function c of m on your calculator. We're going to use decimals here and answer the question: does the function have a maximum or a minimum, and why does this make sense? So let's type the function here. C of m is equal to 17.4 m to the power of 0.25. So this is the graph. And the question, does it have a minimum or maximum? It has actually a maximum at 0, 0, as you can see here. And if you notice, there are no negatives. If you have table of values, if you have -1, below 0 is going to be undefined. Okay. Minimum at 0, 0, and there is no maximum. And also, I showed you that it is undefined when m is less than 0. Okay, let's proceed to number 2. In psychological experiment on memory, students in a language class were asked to memorize 40 vocabulary words in Latin, a language with which students were not familiar. After studying the words for 1 day, students were tested each day after to see how many words they remember. The class average was then found. The function r f of d is equal to 5d plus 30 over d models the average number of Latin words remembered by the student after d days. So take a look at this graph here. You have the x-axis as the number of days. You have 5, 10, 15, 20, 25 days, and the y-axis, that is the average number of words remembered. And we can answer the next questions. Letter A, interpret the point 25, 6.2 in the context of this scenario. Based on this graph, this is 25, so meaning we are talking about this point. And this is 25 and 6.2. Meaning after 25 days, the average number of words remembered is 6.2. Letter B, does this function have a minimum? If so, what is the minimum? And if not, explain how you know that no minimum exists. Based on the function of d is equal to 5d plus 30 is equal over d, we know that it can't be 0. Because when we substitute 0 here, it's gonna be, let's try, 5 times 0 plus 3 over 0. 5 times 0 is 0. 3 over 0 is undefined. So that's why d must be greater than 0. See where is the graph steepest, and what does this tell us about the students? If you go back to our graph, so it's very steep at the beginning, and that tells us that the students remember the words at the very beginning, and it tends to forget the words after how many days, isn't it? Now letter D, if find D when R equals f of d is equal to 11 and explain the meaning of the solution in the context of this problem. Okay, so using this formula here, so if f of d is equal to 11, we can solve for t. You can rewrite this as 11 is equal to, or instead of doing that, we can cross multiply this. That's 11t is equal to 5t plus 30, and then subtract 5t both sides, so that we have 11t minus 5t is 6t is equal to 30, and then divide by 6 both sides, so that d is equal to 5. Let's go back to our graph here. 5 days, so that is the average number of words remembered is 11. So after 5 days, the average number of words remembered is 11. Okay, then letter E. Find f of 365 and interpret its meaning in context, and explain how the graph supports your answer. So let's solve f of 365. So that is 5 times 365 plus 3 over 365 is equal to, we can write this as 5 times 365 over 365 plus 3 over 365. So that is 5 plus 3 over 365 is 0.0822. So this is approximately 5.0822. And that means after 365 days, the average number of words remembered is 5.0822. And as you can see here, based on our graph, if you continue this, it's continuous here, it extends, but it won't touch the number 5. So meaning there is a limit that even after how many days, after 365 days, after 1,000 days, the average number of words remembered is always above number 5, above 5. Okay, so that means you will always remember at least 5 words. The next is find the number of days it takes for the students to retain only half of the original vocabulary words list. Check the reasonableness of your answer by circling the relevant point on the graph. So the students were asked, if you go back to the original problem, were asked to memorize 40 vocabulary works in Latin, and half of that is 20. So find the number of days it takes for the students to retain 20 words. So 20 is equal to 5t plus 3 over t. Multiply this. That is 20t is equal to 5t plus 30. And then subtract 5t both sides. So that 20 minus 5 is 15t is equal to 30. And then divide by 15. So D is equal to 2. So if we go back to our graph here, so here this is 2 and 20. So the number of days is 2. And that means after 2 days, the average number of words remembered is 20. Okay, so that's the last problem for this semester. This is Unit 3, Activity 5. If you have any questions, please let me know. And thank you.